Hi my dear friends, welcome back to our YouTube channel. This is your ADC Maths. I hope everyone is doing fine from your end. Please kindly take care of your health and advance happy Diwali. Please take care. Okay, stay safe. Yeah. This video lecture will give the application of the Fourier sine and cosine transform of e to the power minus ax. Yes, already we know that the Fourier sine transform of e to the power minus ax is root 2 by pi. S stands for sine, so s in the numerator, s square plus a square. So cosine transform is the constant a in the numerator. So that's a big one. Now with the help of this result, already we have seen that the Fourier sine transform of x into the power minus ax as well as the Fourier cosine transform of x into the minus ax by using the property Fourier sine transform of x into f of x is equal to minus d by ds of Fourier cosine transform of f of x, and the Fourier cosine transform of x into f of x is equal to plus d by ds of Fourier sine transform of f of x. I made separate video for this, but this time I am going to find out what is the Fourier sine transform of e to the power minus ax by x and the cosine transform of e to the power minus ax by x. So this time I go for the division of the polynomial term x. So product, we use the property. Now it is a division. How? Let us see the technique. But there is no properties available in the division format. So I use something is different and the usual with the help of the classical definition of the Fourier sine transform and the cosine transform. So my aim is to get the Fourier sine transform of e to the power minus ax by x. So how? This is the first part. So this is the first one. This is the second one. So I got the first one now. So by the definition, the Fourier sine transform of e to the power minus ax by x is equal to square root of 2 by pi integral 0 to infinity e to the power minus ax by x sine transform, isn't it? So this sine sx into dx. So the outcome is f s of s. So our ultimate aim is to get f s of s. Is right? Isn't it? But I do not want this x in the denominator. I don't want this x in the denominator. So what I would like to do that? Very simple concept. So the output is yes, isn't it? The output is yes. So I simply differentiate this with respect to yes and integrate with respect to yes, we get the answer. So once I repeat this, the concept behind this model is differentiate this with respect to yes and integrate with respect to yes, we get the required answer. So that is the ultimate aim of this problem. Now, can I differentiate this with respect to yes on both sides? So differentiate with respect to yes on both sides. What happened? If I differentiate this with respect to yes on both sides, the left hand side becomes this actually fs of s now. So d by ds of f s of s is equal to d by ds of square root of 2 by pi integral x is equal to 0 to x is equal to infinity e to the power minus ax by x into sine sx into dx. Is right? So this is the integrating variable x. Now this is the differentiating variable yes. So when I am going to differentiate this with respect to yes, let's move to this yes term. So what happened is equal to square root of 2 by pi integral x is equal to 0 to x is equal to infinity e to the power minus ax by x. It's free from the yes. So what about d becomes dou? Why this becomes dou? Because x is the integrating variable, now s is the differentiating variable. So we have more than one parameter, so more than one variable. So this comes the partial differentiation idea, is right? So dou by dou s of sine sx. So by this way, what we'll get? Root 2 by pi integral x equal to 0 to x equal to infinity e to the power minus ax by x. What about sine sx with respect to s? Cos sx, and then sx with respect to x, we get x. Sx with respect to yes, we get x. What's the dou by dou s of sx? S is the integrating variable. Now this becomes x. So that's x. Now after getting this, I can cancel the x. That's it. I can cancel the x. So what happened? So this becomes now, after cancellation, we will get the left hand side is d by d s of fs of s, is it? Right hand side, square root of 2 by pi, integral 0 to infinity, e to the power minus ax into cos sx dx. I think so. This looks like exactly the Fourier cosine transform of e power minus x. So already we have the answer in the board. What's the Fourier cosine transform? So is equal to square root of 2 by pi Fourier cosine transform of e to the power minus ax. So is equal. That is root 2 by pi is not there. So this is exactly Fourier cosine transform to the power minus ax. It's nothing but square root of 2 by pi a by s squared plus a squared. So this is the d by ds of fs of s. But I need only fs of s. So what I want to do that? I just do the integration. So integrating with respect to s on both sides. So what happened now? When I integrate this with respect to s, so integral of d by ds of fs of s into ds. So what happened? The integration and the differentiation get cancelled. Is equal to integral of square root of 2 by pi a by s squared plus a squared into ds. That's right. This time we integrate with respect to s. So on the left hand side we got the required one fs of s. Right hand side square root of 2 by pi into a. So constant integral ds by s squared plus a squared. So what is integral ds by s squared plus a squared? It's nothing but 1 by a into tan inverse of s by a, isn't it? The result is there. 1 by a tan inverse of x by a. Here s is the variable. So after getting this result, we can cancel the a. So the answer for the Fourier sine transform of e to the power minus ax by x is equal to square root of 2 by pi tan inverse of s by a. Tan inverse of s by a. So this is my f s of s. Got it? Very simple concept. Very simple. Just nothing I was done. I simply applied the definition of the Fourier sine transform and differentiating with respect to s, and in the output I can do the integrating with respect to x, which will give the required answer. I would like to just extend the same question for the cosine transform. So what's the cosine transform of e to the power minus ax by x? Let's see what is the cosine transform of e to the power minus ax by x. So the question number 2 now. What's the cosine transform? So this is the cosine transform of e to the power minus ax. So this sine sx becomes cos sx. Once again differentiating with respect to x. So now once we are going to get the Fourier cosine transform, this fc of s. So this is the fc of s. When I differentiate this with respect to s to the cos sx. So cos sx, what's the differentiation of cos sx? Minus sine sx into s. So here we get what's the d by ds of cos sx. So cos sx becomes minus x into sine sx. Minus x into sine sx. Once again the x get cancelled. So we get it for minus ax. And the left hand side is fc of x. Root 2 by pi, it equals 0 to infinity, it equals minus ax sine sx dx. Behind the term we have minus n. So fc of s. This is exactly looks like the Fourier sine transform of e to the minus x with the minus sign. The Fourier sine transform of the minus ax is nothing but root 2 by pi s by s squared plus a squared. I made separate video to derive these values. Please go and watch it. Got it? Okay. So minus root 2 by pi s by s squared plus a squared. The same concept. Integrate this with respect to s now. The left hand side fc of s, and the right hand side it is minus behind the term s in the numerator. So what happened now? Let's see that this is the cosine transform concept. Here s in the numerator, last time a in the numerator, so I got the answer 1 by a tan inverse of s by e. But this time something is different idea. What's different idea? Yeah, let's see. I go for the separate space for that. So after this I am coming here. minus root 2 by pi, yes correct. The left hand side we get only fc of s is equal to minus root 2 by pi, is there, no problem. Integral s ds in the numerator, denominator is s squared plus a squared. So I would like to use some proper substitution technique here. Can use theta is equal to s squared plus a squared. What about d theta by ds is equal to 2s into ds, or otherwise d theta by 2 is equal to s into ds, is right? Can I substitute in the place of s squared plus a squared is equal to, so fc of s is equal to minus square root of 2 by pi integral s ds is equal to d theta by 2 divided by, and s square plus a square is theta. So take 1 by 2 outside. So it is minus square root of 2 by pi into 1 by 2 integral d theta by theta. What is integral d theta by theta? Log theta. What is theta here? Theta equal to s square plus a square. So after cancellation of 1 root 2 we get minus 1 by root 2 pi. So 1 root get cancelled here. Minus 1 by square root of 2 pi is log theta. Theta is here s square plus a square. Is right? So what's the Fourier cosine transform of e to the power minus ax by x? Is nothing but minus 1 by square root of 2 pi logarithmic term. It's a natural logarithm of s squared plus a square. So this is my required fc of s. So for a sine transform of e to the power minus ax by x equal to root 2 by pi tan inverse of s by a. But and the cosine transform, this will comes minus 1 by root 2 pi ln this logarithmic of s squared plus a square. If I extend the same for the some other functions, for example, suppose my question is, after getting this value, after getting the Fourier sine transform of x into the power minus x by x and Fourier cosine transform of e to the power minus x by x, and hence find out the Fourier sine transform of e to the power minus x minus e to the power minus 3x by x. Suppose the question is coming like this. Very simple. By using the linear property, this can be rewrite for a sine transform of e to the power minus x by x and minus for a cosine, the sine transform of e to the power minus 3x by x. So already we know the value for a sine transform of minus ax. So we substitute a equal to 1 here, a equal to 3 here, we get the answer. Square root of 2 by pi tan inverse of s by 1 minus square root of 2 by pi tan inverse of s by 3. That's it. Take 1 root 2 by pi is a common, tan inverse of s minus tan inverse of s by 3 is the answer. The same way, suppose the question is, what will be the answer for the Fourier cosine transform of e to the power minus 2x minus e to the power minus 4x by x? Okay, again the same idea, by using the linear property, Fourier cosine transform of e to the power minus 2x by x minus Fourier cosine transform of e to the power minus 4x by x. I made the separate video for the properties of Fourier transform, complex Fourier transform, as well as the properties of Fourier sine and cosine transforms. Okay, please go and watch those videos. So by using the same idea, here a equal to 2 and here a equal to 4. So by using this concept, minus 1 by square root of 2 pi log of s squared plus a squared, x squared plus 2 squared minus of minus 1 by square root of 2 pi log of s squared plus 4 squared. Is right? So minus or minus becomes plus 1 by square root of 2 pi taken outside. So the positive term is log of s squared plus 16 minus this minus term now log of s squared plus 4. By using the logarithmic rule, log m minus log n is log m by n. So the answer is 1 by square root of 2 pi log of the base e of s squared plus 16 by s squared plus 4. So that is the answer. I hope everyone may understand this idea with the help of the Fourier sine and cosine transform e to the power minus ax. How to get f of x by x, that is e to the power minus ax by x, and under the sine transform as well as the cosine transform. Under the sine transform it is root 2 by pi tan inverse of s by a. The cosine transform is minus 1 by root 2 by pi and logarithmic of a squared plus a squared. That's it. And this is with the help of the linear property. Right? I hope everyone has enjoyed this video lecture. Please kindly subscribe, comment, share to your friends. our YouTube channel ADC Max. Thank you so much for watching our YouTube channel. Thank you.